I've been reading about machine learning, and it seems like algorithms are the heart of the entire process. But I'm having trouble understanding exactly what they do. How do they work with data to make predictions?
That's a great question. You're right, algorithms are indeed the heart of machine learning. They're the set of rules or processes that the model uses to learn from data, recognize patterns, and make predictions. Essentially, algorithms process the data you feed them, find relationships or structures in it, and use that information to make decisions or predictions on new, unseen data.
I see, so the algorithm is like a brain that learns from data? How do they know what kind of patterns to look for?
Exactly. Think of algorithms as the brain of the system. They don't know what to look for at first, but as you give them more and more data, they start recognizing patterns. For instance, in supervised learning, you give the algorithm labeled data, meaning you already know the right answers. The algorithm tries to find the best patterns in the data that connect the inputs to the correct output.
Ah, so it's like teaching the algorithm to predict outcomes based on examples. But there must be different types of algorithms for different tasks, right?
Yes, absolutely. There are many types of algorithms, each suited for different kinds of tasks. For example, decision trees are great for classification tasks where you need to categorize data into predefined classes. On the other hand, neural networks are often used for more complex tasks like image recognition or natural language processing because they can learn more intricate patterns.
That's interesting. Can you explain how a decision tree works? I've heard it mentioned a lot, but I'm not quite clear on how it actually makes decisions.
Sure. Imagine you're playing a game of 20 questions, where you try to guess an object by asking yes/no questions. A decision tree works in a similar way. It splits the data based on specific features or attributes, like is this a fruit, or is the color red? Each question or split creates branches in the tree. The deeper you go into the tree, the more specific the decisions become, ultimately leading to a prediction at the end.
So, the decision tree keeps splitting the data into smaller and smaller groups based on the questions it asks. But what about neural networks? How are they different?
Neural networks are inspired by the human brain. Instead of making clear, rule-based splits like a decision tree, neural networks have layers of interconnected neurons that process the data in a more fluid and complex way. These layers allow the network to learn patterns at various levels of abstraction. For example, in image recognition, the first layer might detect edges, the next might detect shapes, and the deeper layers might recognize objects like faces or animals.
That sounds much more flexible than a decision tree. So, neural networks are good at handling complex data like images and text, but they need a lot of data and computing power, right?
Yes, exactly. Neural networks are very powerful but can be computationally expensive, especially deep learning models. They require large amounts of labeled data and processing power to learn effectively. This is why they've become so popular in fields like computer vision, natural language processing, and even in self-driving cars.
Got it? So how do these algorithms learn? Is it just by finding patterns in data, or is there more to it?
It's more than just finding patterns. The learning process involves optimizing a mathematical function, often called a loss function or cost function. The goal is to minimize the difference between the algorithm's predictions and the actual results. For example, a neural network adjusts the weights of its neurons during training to minimize errors, improving its predictions over time.
Oh, so the algorithm adjusts itself based on feedback during training. It's like learning from its mistakes, right?
Exactly. It's just like humans learning from experience. The more feedback an algorithm gets, the better it becomes at making accurate predictions. In fact, this process is called training the model, and it involves iterating over the data multiple times to continuously improve.
This is starting to make sense. But how do we decide which algorithm to use? When should I choose a decision tree over a neural network, for instance?
Great question. The choice of algorithm depends on the problem you are trying to solve. If you have a relatively simple, structured dataset, decision trees might work well. They're interpretable and easy to understand. But if you're working with more complex data, like images, text, or large datasets, neural networks or even deep learning models are often the better choice.
So, it's about matching the algorithm to the task at hand. I can see how important it is to understand these different algorithms. But once you choose an algorithm, what happens next?
Once you've chosen an algorithm, you'll train it using your data. After training, you test the algorithm to see how well it performs, and you tweak the parameters or try different algorithms to improve the model's accuracy. The goal is to get the best performance possible on new, unseen data, which is what we call generalization.
That's really helpful. It sounds like algorithms are the backbone of machine learning, guiding the entire process from learning to prediction.
Absolutely. Algorithms process and learn from data, which is how machine learning makes predictions. Whether you're working with simple models like decision trees or more complex ones like neural networks, understanding how these algorithms work is essential for building successful ML models.
Thanks for breaking it down. I feel like I have a much clearer understanding now of how machine learning algorithms work.
You're welcome. Keep exploring, and remember that the more you practice with these algorithms, the better you'll get at choosing the right one for the right problem.